your phones out of sight while I'm teaching because you can't help it. If it makes that little sound, a buzzing sound, that you got a message, you can't help it, right? You can't. Look at me. I'm putting mine away too. So just be polite and fake it if you have to, if you're listening, okay? All right, so we are moving on to 1.4, and this is all about sketching a graph given some information. So we're going to do 2 examples together, and then half of the homework together. And I'm going to give you guys graph paper to do the homework together. So we're going to do 2 in the notes together. Then there's 8 in the homework. I'm going to do 4 with you and leave you 4 to do, and I'll put up the key, okay? So this is something you definitely want to pay attention to. This is kind of putting together a lot of the things we've already learned, and a lot of things we've already learned, and maybe some new ideas, okay? So I'm just going to quickly kind of go through these key features. These are all really important features of graphs, okay? Phone, Dylan. Okay, because guys, I am having that phone caddy hung back up again because I force my pre-calc kids to have to put it in as they walk in the door. Right as they walk in the door, they put their phones in there. And I check it to make sure every single person, and it takes time. If I have to do it with you guys, I will. I'm trying not to. I keep warning you though, but I will. You'll see my mean side. Okay, so these are the key features. Domain and range we've talked about pretty much almost every day. But domain are your X values and range is your Y values. Sometimes students get them confused, and just think of the alphabet. X comes before Y in the alphabet, and D comes before R, so if you get confused. And f of x is the same as y, okay? Intercepts, we should know that. That's going to be a big part of what we do today, where the graph crosses an x-axis or a y-axis, where it actually touches that axis. Those are your intercepts. And remember, the other number is 0. So for an x-intercept, y is 0. For a y-intercept, x is 0. And we're going to see that here in a second. We've been talking about end behavior last couple days, so we'll see that again. That's just what the arrows are doing on the ends of your graph. Okay, extrema, we've talked about that for the last couple of days, the mins and the maxes. Increasing and decreasing, so increasing and decreasing is like the most basic concept. Increasing is it going up, decreasing is it's going down. And we did that like, gosh, it seems like a week ago. But just if you just look at a graph, it's like a roller coaster. Going up is increasing, going down is decreasing. And positive, negative is kind of, I don't think we've talked about that, but it's literally where the graph is above the x-axis is positive and below is negative. So all these things, or most of these things, we'll talk about within the examples, okay? So I'll come back to a lot of those thoughts. But if you want to read what it is, like if you get stuck, you can see all the definitions there. So in our first of 2 examples in the notes, they've already done the graph for us. And if you remember, I changed how we do end behavior. I crossed out a lot of stuff. I think it was yesterday. So I'll be giving you the end behavior for these. So this is done for us, but we're just going to analyze what is given to us and how it applies to that graph, and then we'll do one from scratch, like where we have to graph it, okay? So it gives us a y-intercept. So you notice this y-axis is labeled counting by 20s, right? 20, 40, 60, 80, negative 20, and so on. So there's my y-intercept at negative 70. It's in between those two. Sorry, I made it a little bit too big. Linearity, fancy word. Is it linear? Yes, that means it's going to make a line. Okay, and we're going to do one in a second. That's not linear. Positive. Where are the numbers above the x-axis? So be able to read this. Look, look, look. Where x is less than negative 30. So where is negative 30? That's about right here, right? Right in the middle of negative 20 and negative 30. Look how all the numbers less than negative 30, so that's to the left, numbers to the left, are all positive. That means they're above the x-axis. So those are positive, these are negative. Okay, so that was given to us. Decreasing. Where is the graph just going down? The whole thing, right? In a line, the whole thing is either going up or going down. Since this is a negative slope, we're decreasing. And the end behavior matches, there's my up, there's my down. So up, down matches, okay? So this one was done for us. Let's do one that's not linear, and we'll take the information given and put it on the graph. This takes some it takes some getting used to in the beginning, and then after we do a few in the homework, I think you guys can be like, wait, don't I just do this or don't I just do that? You're going to see they're pretty easy. But you do need to listen here in the beginning so you don't get too confused. Okay, so go to example 2. Do me a favor and change the end behavior to up, up. Rises to the left, rises to the right. And we're going to go through the different pieces of this graph together. Okay, so let's look at all the different pieces of the graph and let's start labeling. So first thing we see is y-intercept, 0, 3. So I'm going to go on this graph they give me. Notice how they're counting, guys. So it's 2, 4, 6, 8. So 3 would be in the middle of 2 and 4 on the y-axis, okay? So between 2 and 4. So let's say approximately right there. Right? And again, there's my x value, that's 0. Y is 3. All right? It tells, and it doesn't really matter the order we do this in, so we did that one. Linearity, it's not linear. So all we know is it's not going to make a line. Okay, this will not be a line, which kind of makes sense if you look at the end behavior. And a line, the end behavior is always going to go in 2 different directions. Okay, so fine, we understand that. We'll worry about it later. They're going to put continuity on all of these. All that means is we're going to put arrows on the ends. Okay, we'll talk deeper into what continuity is later. But there's things called asymptotes and holes in graphs that make the graph not continuous. All of these are continuous, like you can connect all the points with a smooth curve or a line, arrows on the end. So don't worry about that. That's going to be written for all of them. Okay, all of the values of x are positive. That means there's going to be absolutely nothing below the y-axis. Every single value is above, okay? So positive is above x-axis. Okay, that's what that means. Decreasing, okay, so it's like a little, oh sorry, I'm sorry, can you see that, Tommy? You can't see stuff, guys, I'm so sorry. Decreasing, so we have to, it's like a little puzzle. It's almost fun. Let's think of it as fun. Decreasing is where the graph is going to be going down, right? Increasing is where it goes up. Not positive or negative, just it's like a roller coaster, down and up. That's decreasing and increasing. So understand how to read this. For all values such that x is less than 0. So for the numbers to the left of 0, less than 0 is to the left, all the negative numbers, our graph is going to be going down. Okay. Let's wait on that. It's going down. Okay. There's a minimum at 0, 3. Well, we already graphed that. That was our y-intercept. And we know our end behavior. From just that information, we're going to sketch a graph. Okay. Now, sketch means just that. It's not perfect. Don't ask for a ruler. You don't need it. This isn't a line anyway. It's not going to be perfect. But if we meet all this criteria, we're good. So let's back up to decreasing. So all the numbers to the left of 0 are going to be decreasing. So I'm just going to estimate. Let's call it like that. These are all decreasing. And it's not a line. That's why I didn't make it straight. I put a curve on it. We know it's going to be going up on the left side. And if all of the, let me see, is there anything else? So if we're decreasing over here, it's very specific. We're decreasing here. What do you think we're doing over here? Increasing. It's a parabola. Can yours be skinnier than mine or fatter than mine? Sure. Okay, we still meet all those criteria. It's continuous. Our end behavior is good. Every single value is above the x-axis. Okay. So hint, hint, you're either going to make a line or a parabola for all of these problems, okay? And it takes a little bit of practice, but this is great practice for understanding what all these things mean, okay? So I'm going to give you guys a piece of graph paper right now while you fix, sorry, we're almost out of the book. When we get to 1.5, I'll write my own notes. It'll be so much better. So what I want you guys to do while I walk around and give you a piece of graph paper is for your end behaviors on the homework, so go to page 37. Here's your assignment. And I'm going to do the first 4 with you. Okay, so don't stress. All you're doing right now, and I'll move it up in a second, is fixing the end behaviors. Okay? Sorry that you have to do that, but we do the best we can. So go to that page, write the assignment down. If you write really big and you end up needing another piece of graph paper, I will happily give it to you. Okay? All right, guys. Okay, you are fixing your end behaviors. There's the rest of them. All right. I'm going to do the first 4 with you, okay? All right. If you didn't change the end behaviors, it'll go back up in a second. So you have this page in your notebook. Like I said, this is why we have a 3-ring binder, so we can open it when you're ready to, and you can put this in there. So this is A8, page 37, 1 through 8. And I'm going to do the first 4 with you, and by then you'll be totally fine, okay? You can write on the back. Again, if you need more paper, I will happily give you more paper. Okay, so let's start with number 1 and see what we have. So what I would do for these is just start out by maybe sketching a graph. Okay, so that's why I gave you graph paper. We can make it a little bit nice and just do like an X and a Y axis. Okay, and then we'll start adding to it. Now this, I jumped right into this one that it's a line. I know this is a line, so let's see what they gave us. They gave us an x-intercept of 2, 0. So to the right 2, up or down 0, that's an x-intercept, right? A y-intercept at 1, 2, 3, 4, 5. I need to extend my graph, no big deal. 1, 2, 3, 4, 5, 6. So on the y-axis at 0, -6. The truth is, guys, for a line, and we know it's a line because it says it, you only need those 2 points. You could totally make your graph from this, and I'm going to do that, but then I'm going to just go over how we already met all the criteria, okay? So it does not have to be perfect. Don't worry about using a straight edge. It's perfectly fine. We are sketching. And that's really the end of the problem, but let's go back over some of the other things. We covered the first 3. Continuity, we already talked about. You're going to see that the whole page, they're all continuous. Positive, all the values from to the right of 2. That's what that means, greater than 2. So here's 2. All the numbers to the right should be above the x-axis. Those are the positive numbers. Good. That's what we have. And it's increasing for all values. Increasing means it's got a positive slope. We're going up the hill. Okay? So lines are our favorite because they're the easiest. Okay? For the second one, go ahead and draw yourself an X and a Y axis. Question on number 1, anybody? Okay, so, another line. That makes us happy. The linear ones are our favorite, okay? But here's what's bad about this problem. We can put our x-intercept right there, but guess what? Our y-intercept is the same place. We need another point. So unlike number 1, when we just had an x and a y-intercept that were different, we could just be done. So we're going to have to use the rest of the information. Okay, we already know they're all continuous. All right, for the numbers less than 0, So that's left of 0. So all the numbers to the left are going to be positive. Okay? All right. And all the numbers that are to the right of 0 are going to be negative. So how do I know where my line goes? Oh, and by the way, the whole thing is decreasing, so it has a negative slope. Okay. Matthew? Say it one more time, Matthew. Well, negative simply means all the numbers to the right of 0 are going to be lower. Let me come back to that. I'm going to circle back to that, but I just want to see first, does anyone know how I'm going to write this line? What am I going to do, Amanda? Decreasing, and I'm going to go right through what? The origin. I love how you said that. So guys, look, this is what it's telling us to do. And now I'm going to go back and read and help you with that, okay? So listen, shh, positive. Positive means these numbers. These numbers are the positive numbers. These numbers down here are negative. So what that means is all the numbers less than 0, that means to the left of 0, are going to be up here. And all the numbers that are greater than 0 are negative, okay? So positive and negative just means on the y-axis, up and down. I know it's a little confusing. It takes a few to get used to it. Does that make sense, Matthew, a little bit more? Okay. Let's keep going. So that one was kind of a harder one. Let's do 3 and 4 together. This is homework, so hopefully you guys are writing it. No sleeping. Okay, so this one, okay. This one is also linear, and we have 2 different intercepts. That's our favorite. We love that kind. These are the easiest ones because all you need to do for a line is have 2 points. I'll still point out the other ones. So there's 1, 2, 3, 4, 5, 0. There's my x-intercept. My y-intercept is 1, 2, 3, 4, 5. And that's enough for me to make a line. Favorite type of graph. But let's, again, like I said, go over the other parts. Okay? So we graphed the x-intercept, the y-intercept. We know it's linear. We know it's continuous. Fine. So look, all the numbers less than 5. So here's 5 right here. And the numbers less than 5 are in that direction, right? So all of these numbers should be positive, which means above this. And they are. Look, all of those numbers less than 5 are above the axis. These are all positive numbers. They also gave us decreasing for all of them. That means it's a negative slope, so it makes sense that it's slanting like that. Okay? But we didn't really need all of that for that one. Okay? You guys are doing a great job. Thank you. Yes, I was. I was talking to Shane. Again, with the x-intercepts, I'll do a nonlinear one with you too, though, in a second. So x-intercept is 1, 2, 3, 4, 5 again. Same one as the last problem. Y-intercept is 0, 2. So really, that's enough, right? But just like the last one, I will go, see how dumb this book is? It's just dumb. Like, why did they do all 4 of those in a row like that? I just think they just do a poor job. Anyway, we had our intercepts. We understand linear. We understand continuous. So all the numbers less than 5 should be above or positive. There they are. Look. All the numbers to the left of that 5 are above our axis. And it's decreasing, just like the last one. So it has a negative slope. Okay? Let me finally, I said I was only going to do 1 through 4 with you, but looks like I'm about to do 5 with you as well. I want to do a non-linear one. They're harder, I think. Okay, let's see what we have. we have two x-intercepts, okay? We have -1, 0, and 1, 0. So that's the two x-intercepts right here. We have a y-intercept at 0, 1. Okay? We just talked about how it's nonlinear, so you know it's going to be a curvy graph called a parabola. Okay? And we know it's continuous. Don't worry about the symmetry. There's some symmetry we didn't do in here, so don't worry about that. But positive, okay, so this is the part we were getting confused about. Positive for values from -1 to 1. So what that means is, I'm going to use pencil, from here to here, all of that part of the graph should be above the line. That's what it means. So knowing that this is going to be a parabola, you can probably already guess what the shape is going to be, because it's saying these points right here are positive. That's what that means. From -1 to 1, all of the points on the graph are positive. Okay? And then let's keep going. We're negative when we go less than -1, and negative when we're greater than +1. So that just means continuing on like this. But I bet you could have guessed that, even if you didn't keep reading. Increasing all the way up to 0, that means positive. Decreasing after 0, which means negative. That's the rest of it. And the end behavior was down, down, and that matches our picture. Okay? So I'm going to put the paper back up in case you did not finish writing down the end behavior, and then I'll put the last 3 up for you to check your answers. But I want you to try. So fix your end behaviors if you didn't on those last few, and then I'll put up the key. Yes. Yes, thank you for waiting till I was done educating you. Oh, you did. I'm sorry, Harris. Okay, so let me put the key up. I already did number 5 with you. I just happen to have 6, 7, and 8 on the same page. So, guys, this is not for you to copy. Try to understand it. Don't just copy it. What? Well, the homework was 1 through 8. We just did 1 through 5 together.
No pressure.
Someone is out when she comes back. When you hear the door, you're up. No, I'm just showing you like why, where I got it from, just to help.
Mm-hmm.